Hi folks, I'm Lingfan Gao, a senior software engineer at Microsoft working on Fluent UI. And this is another episode of Fluent UI Trainings. In the Fluent UI repo, we've created this, what we call the styles handbook. And it's just a kind of like a compilation of all the experiences we've had using our CSS-in-JS engine, Griffel. And this styles handbook includes a lot of best practices and how to introduce users to core concepts of the CSS-in-JS system that we use. So it's a great resource for new people who join our team, or a great resource for people who we collaborate with who work in apps like Microsoft Teams or Office.com. And we kind of just pass this around and show them, like what are the best ways you can use Griffel. So in this episode, we're going to kind of go over a few of these different best practices and show you why they're important and how you can apply them to your projects. If you use Griffel as a CSS and JS engine, it's not even Fluent. It's definitely worth taking a look at the styles handbook. So on the Griffel doc site, we have a page called limitations. And the main part of this page is actually just about how to handle runtime styles. And what are runtime styles? So let's go to a code example and see. In this example, we've naively tried to change the color of a div based on a user prop. You can see that we have, a props object, and the prop should have a color, and we try to apply that, color into the CSS definition. This will not work, and this will never work in Griffel. And this is kind of due to, the objectives of Griffel, what we're trying to do with it. We're trying to make a no runtime CSS and JS solution, which means that if we have styles that depend on the runtime, we can't know how to extract it at build time. Griffel has a lot of extensions and plugins for bundlers where we try to extract the styles at build time so we can just put them on the page as plain CSS. So how do we work around this? So the first way to work around this is probably the most straightforward, and it should apply to almost 80% of the cases out there. So the example we're going to go for is just a simple grid layout pattern. You can see kind of here that we have, a two-row grid layout, a two-column grid layout, a three-column grid layout, and a four-column grid layout. And this is kind of defined, right? It doesn't really make sense for us to have anything more than four columns on a page. Maybe it does, maybe it doesn't, but you can't go too far. And in this case, all we do is enumerate all the possibilities. So when we make our Griffel CSS definition, we can obviously, make our container definition with display grid, but actually we create extra style definitions which correspond to the number of columns, and then we compose these styles with each other. You'll see that in the final div, we always apply our container styles, which is going to have the display grid, but for the column template, we listen to the prop, and based on the prop, if it's 2, 3, or 4, we apply the corresponding style. As I said, there's not that many columns you can really have in a grid layout in a page that actually makes sense, so even if it's 10, it's worth just declaring 10 different styles and just applying them based on a key. So the next way you can support runtime styles is by just using inline styles. There's no real consequence of using inline styles, and it's pretty handy and it's pretty quick. So if you have a color, for example, where you want to match a border color to a prop color, you can just apply the border color in inline styles and style everything else using Griffel. But the one drawback of using inline styles is the specificity problems, right? If you're going to make a reusable code and you rely on inline styles, it's going to be very hard for someone else to override your styles even using Griffel, because inline styles will always have a higher specificity than anything in CSS. So that brings us to probably the most advanced way of trying to handle and work around this problem of runtime styles, which is using CSS variables. So this is an example here. If I hover over these text paragraphs, you'll see that the color changes. And how do we handle this color change? This color change should happen at runtime, and it should change based on user prop and based on what we set it to be. In this case, we can have a color picker. We can change it to blue, right? We can have a color picker for hover, change this to red, and we should change this at runtime. How do we do that? You can see here we just declare CSS variables, so a text color and a text hover color. And we declare all our styles like we normally would, but when we get to color, for either hover or for the rest state, we actually use our CSS variables. And what we end up doing in our code is that we apply, instead of applying color as an inline style, we apply the CSS variable as an inline style. So we don't really have the problems of specificity anymore, because you're not really going to override a CSS variable an inline style, if someone's going to override it, they're probably going to know what they override it with. And if they're going to override your style, they can just use another CSS variable and apply that inline as well. So you don't really have the specificity issues, and you're only changing a CSS variable, which is of little consequence, let's say. So all the other style definitions can stay static, and the only runtime part of it is just assigning inline style to your element. So let's go to using structured styles. So what do we mean by structured styles? It's kind of like a way of organizing your different style definitions using Griffel in a make styles call. We saw earlier, for example, that we can try to enumerate all the variants at build time to apply them at runtime with this grid layout, right? And you see here that we have something along the lines of a grid 2, grid 3, grid 4, and we apply them individually, right, based on the condition of the prop. But we don't have to do that. We can actually try to be a bit smarter here. So in this case, we have, a component, let's say, with different text sizes. I want to apply these sizes based on a runtime prop. So what we can do here is we can actually make the size prop match our style definition names. So you can see that the sizes our example component takes is small, large, extra large. And then you have also style definitions that are called small, large, and extra large. And using merge classes, we can apply these in our different examples using a prop. So let's go to our example and take a look at what it's doing there. It has a merge classes definition, and the base is always applied. So this is just the default state if there's no user overrides at all. But if there is a prop, we can just get our classes and map that to the prop that we get. So instead of having to enumerate each and every single condition like we saw earlier with our grid layout here, we're actually just selecting the proper layout according to a map, essentially. So with these kind of handy organizational tricks, you can really do this job of enumerating all your different options, but not actually making the code look really, really big. So now let's talk about the importance of tokens. So what do I mean by tokens? Tokens are CSS variables that we've defined in Fluent UI, and you can use those CSS variables for a bunch of different things like colors, spacing, border radius, as you see here, and even other things like font weights and so on. And why do we use these, design tokens? There's a lot of reasons, but mainly it's for theming. We want to standardize the Fluent UI theme, and we want to make sure that there's as little risk of conflict between themes as possible. What does that mean? So in this example, we've defined 2 different types of styles, right? So in the first one, we have a bad example. We've decided to, color some text. We've decided to make it color black. And in the good example, we've decided to, make it color neutral foreground 1, which in this case, as you can see, is still black in the good example. But this black will change based on the theme you applied, which means that here you can see we have Teams light theme and Teams dark theme providers in each of the examples. In the example where you only use a black color, a hard-coded color, it doesn't really change when the entire provider changes to dark mode. So suddenly your black text is more or less unreadable. But in the good example, this token is actually changed. It's swapped. It's a CSS variable. It's swapped to be white instead of black. And all of a sudden, when you change theme, you have no real problems to worry about anymore. We've made sure that our themes work in all of the theme transitions. But even if you don't use our theme and you define your own theme, it's still worthwhile to make them design tokens with CSS variables. And that's because it's 2024, right? We all want to support dark theme. We all want to support high contrast. You want to make sure that these theme transitions are seamless and they have as little impact as possible in your code. So by using these design tokens, you can write code once, and those styles will work for every single theme. So this is another really simple topic that's more about how to use CSS than it is about Griffel in general. It's a question that's been debated ever since I became a developer, and that's whether you should use !important in your styles. So normally, in Fluent UI, components are authored so that the style should be pretty easy to override. But you can see here that to override the original style, where the color is black you have quite an interesting specificity problem, because this selector here is, some hashed class name, but also using a pseudo selector with enabled, and then also a not pseudo selector, but then also using a combinator to target a slot called switch label. It's a bit of a handful. We try to avoid these, but sometimes it's inevitable that we have some pretty specific classes. And in this case, users should probably not use !important, because this creates bigger problems down the line. In a large app, as soon as you use !important, it becomes very hard to tell how to override it. The only way to override it is to use a more specific rule, but also with !important. And that's generally where the specificity wars seem to end up in. So instead of doing that, there's every tool at your disposal to write styles to override specific styles from Fluent UI. In this case, just inspect DevTools, take a look at the rule you see here, the specificity, try to copy that, right? So you see that we have enabled, not checked, a combinator, and switch label. In this case, we do the same thing. We use enabled, not checked, and then use the SAS ampersand to add the nested combinator. And then we use the switch class name for the label slot. In this case, this works a lot better. It's also, works as expected, because we only wanted the not checked state to have brand foreground, but in the bad example, it fails at even that. That's just because of the inflexibility of using important in this case. So don't be afraid to open up your DevTools, look at what the styles are there, and then try to override using normal CSS. You shouldn't need to use important. So this one is a really important topic, and it's been very, very prevalent across our work at Microsoft. This is about what's known as nested selectors or nested combinators, which essentially we're trying to reduce the amount of combinators inside a CSS rule. And a combinator could be anything from a space, which targets all descendants in CSS, or it can be a sibling selector, or it can be direct children of an element selector. And these just add to the general complexity of, the CSS that you're writing. But also there's some performance aspects in there, which means that for a lot of these combinators, there's a certain amount of browser overhead to actually calculate the styles and find out what matches. And in a large-scale application like we deal with in Microsoft, for example, Teams or Outlook Online, this cost adds up and actually makes the entire rendering of the application slower. But also, from a general point of view, a lot of the times when you're using Fluent UI components or when you're using Griffel, these combinators and selectors just aren't really necessary. So one of the most common cases that we see people use these nested selectors is for actually a valid case. It's for when you want to change styles on hover. So in this case, you want to make sure that you want the button text to change size when you hover over it. And the only real way to make that happen is to use a hover pseudo selector and then apply that style to the actual button itself, but then make a nested combinator that targets descendants and target the root of the button. But there are cases where it's really, really not necessary. And in this case, it's to change the color of the icon. So in these cases, in both of these examples, you can see that we want the color of this 24 icon to be red. And this is done in different ways. In the first way, we have a combinator that targets the button class name, so the icon slot of the button, and applies color status danger foreground red. This really, really isn't necessary. Let's take a look at how this is being used. So in this example, you can see that we're applying this target to the root button. But remember what we talked earlier about advanced slots and how there's a concept of a slot longhand? You can add a class name directly on the icon slot itself. So there's no real need here to actually target a nested class. You can just simply write color red and apply it to the icon. Fluent UI lets you access every single DOM element that's rendered, so there's no real reason to want to apply these nested combinators. It keeps things simple and also avoids those performance problems at scale that I talked about earlier. There's another aspect about Griffel is that it uses atomic CSS. And in atomic CSS, simpler CSS classes are better. And they're better because they're reusable. In cases where we're trying to hover over a button and we're trying to change the text, if we use a simple hover pseudo selector and target the button to change the size, any other pattern that uses this style is reusable. because, we're just hovering using the button class name and changing the font size. It's even simpler if it's a static style. If we don't have hover, you can just add a class to, change the font size to be that. And that's reusable for any time you want to change the font size to, font size base 500. But in this case, if we deliberately want to make this more complicated than it is, we can add wrapping divs, wrapping spans, and we can target and target and target, and it just goes on and on and on. And if we inspect in DevTools the final style of this to make this font 500, so let me just go here and inspect this example. So let's make the hover pseudo selector happen here. And then let's inspect the styles of the button text. You can see that this creates a chunky CSS selector. We have hover, we have container inner, button wrapper, and then finally the button. There's no reason for all of this. And what happens is it makes this rule very unusable, because it's very unlikely you're going to have a similar DOM structure that does the exact same styling somewhere else in your application. So at scale, these rules just grow and grow and grow, and they never really stop. Because compared to a simple style like what you see under it, which is line height, you can see that this is simply line height base 400. Anything in your entire application that uses line height base 100 will reuse this rule. So try to keep these simple, and remember that when you're using Fluent UI components, you can apply classes to any slot, any HTML element. So you can really try to optimize here and just make style definitions for the element itself instead of trying to target things using combinators. So let's talk about icons in Fluent UI. In Fluent UI, you've probably seen in some previous trainings how to use icons, how to put them inside slots, and how to style them. But let's just do a quick recap now of how to style icons. So in this example, we have a send icon, which is this paper airplane icon. And we have two styles declared, which is one is for size, and we change the icon size by using the font size CSS property. So in this case, with font size 20 pixels, the icon's 20 pixels big. And we also use text color to change the color of the icon. So we use the CSS color property. In this case, styling is pretty simple. We put our send regular icon that we import from @Fluent UI React Icons, and we put it inside a div, and then we apply the classes to a div to style the icon to be 20 pixels and red. Where it gets interesting though in Fluent is that we have icon variants. And this is why we're importing a send regular icon and not a send icon. There isn't really a send icon that's exported from any libraries of Fluent UI. And that's because each icon in Fluent UI has a regular and a filled variant. So if you look at this example here with regular and filled icons, the regular variant on the left is just an outline of the paper airplane that shows, the shape of that icon. And the filled variant also fills the icon with a solid color. And you can change that color to be whatever you need it to be, styling it the same way as we have before. And in some of our designs, we have to change between the regular icon and the filled icon. And how do we do that? So if we look at the next example, we can see that we've made a little toggle button to change between the regular and the filled icon here. And we need some effort in user land to make this work. So you can see that we have a utility function called bundle icon as a part of @Fluent UI React Icons. And it takes as an argument a filled icon and then a regular icon and puts them together into one component. And that's what we call here the send icon, right? And if we look at DevTools, what this utility function does, let's inspect our icon variant here. You'll see that when I've toggled it to be the regular icon, there's actually a new class name now that wasn't there before on the icon. It's called fui-icon-regular. And that's just the generic class name for a regular icon. And if we toggle, now again, you'll see there's another icon called fui-icon-filled. So both of these icons are mashed together into one component. And the difference is to toggle them is that we have to use a display CSS trick to display one icon and make the other icon display none. So when we're toggling between the icons, both icons are always there. We're just toggling between which one's hidden and which one is visible. And in Fluent UI, a pretty common pattern is to actually change the icon variant on hover. So when you hover over a button or some other control, you'll see that the icon actually changes from the regular version to the filled version. And the same practice applies here. It's just another CSS trick. But instead of applying display on a static case, we actually put it under a pseudo class. So we use the hover pseudo class to apply display none to the regular icon class name, and then we apply display block to the filled icon class name. So when you hover over, you'll just see that the regular icon has display none and the filled icon has display block. Simple as that. So as a bit of a quality of life improvement, a lot of the Fluent UI components already support these kind of hovered icon transitions. So you'll see in the last example here that I have Fluent UI component hover icons. I've just made a button, right? And this button has a prop appearance transparent. And as a part of the design contract of this component, for transparent buttons, we have this, regular and filled icon behavior when you hover over it. And this happens automatically. There's no need for those like CSS tricks. We've just included them as a part of the component. But the important part is that users still need to bundle a filled and a regular icon together for this to work. But as a general rule of thumb, for a lot of controls in Fluent UI, the icon slot should handle a bundled icon. So if you don't really mind having both icons in your application, even if you don't use them, if you only use bundled icons, you should always get this hover behavior out of the box, like this. That's it for this episode of Fluent UI Trainings. We hope you have more tools in your toolbox for successful web development with Fluent UI, and we'll see you in the next episode.